Welcome viewers. In this video we will see the details about tie set schedule available in the network topology. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. In network topology, the tie set schedule. We know that the network is nothing but the combination of elements: resistor, inductor, capacitor, voltage and current source. If you represent the network by the line, is called a graph. The directions also given in the graph mean oriented graph. Then we have the incident matrix. That matrix will give the details about how many nodes, how many branches, whether the current is going towards the node or away from the node or not connected. That details is available in the incident matrix. So we have network, graph, oriented graph, incident matrix. And also we have the tree. From the graph we can draw the n number of trees. Tree is the subset of the graph, contain 2 or 3 branches but not a closed loop. So from this tie set schedule is based on the tree. Now we'll see the details. Imagine a tree of a given graph. From the graph we can form the several trees. Addition of a link to the tree result in closed path or loop and link currents. So tree is the subset of the graph. So graph contain 4 or 5 networks. The tree can be contain 2 or 3 nodes with the few branches but not a closed loop. Suppose the tree is closed with the loop and link current, then it is called a tie set schedule. So tree with the closed loop or loop and link current is the tie set schedule. Now we'll see the further detail. The current in any branch of the network may be obtained by noting the link current flowing through the concerned branch by taking into account of both magnitude and direction. So current in any branch of a network can be calculated from link current flowing through the branch. So from the link current we can able to find the branch current. So as an example, consider the following graph. How we are finding the branch current from the link current. So this is the graph called a oriented graph. This is a network. Network is replaced by the line and directions also given. So it's a oriented graph. So 4 nodes are available. 1, 2, 3, 4 and this one. 5 nodes are available. There are 8 branches available. 1, 2, 3, 4, 5, 6, 7, 8. So these are all called the branches. 5 nodes with 8 branches are available. So from that we can draw the tree. I already told tree is the subset of the graph, not a closed loop. This is the one type of one tree. Like that we can have n number of trees. So the maximum possible tree formula is available. Determinant of A multiplied by transpose of A will give the maximum number of trees. That is different. Here we consider one tree. If the tree is closed with the link, then it is called a tie set schedule. Now consider this tree. We are going to draw the tie set based on this tree, right? Here the branches 5, 6, 7, 8 are available. 1, 2, 3, 4 is not available here. Now we'll see how to convert this tree into tie set, right? So from graph we drawn one tree. Like that the n number of trees are there. But here we consider this tree. We'll see how to convert this tree into tie set. So the branches are numbered as 1, 2, 3 up to 8 and the directions are given for branches by random. Directions are given by our own, randomly given. So that let I1, I2, I3 up to I8 be the branch currents. Based on the previous diagram, 8 branches are there. That is marked as I1 to I8. Now consider this diagram. This is the tie set. So this is the tie set. We will see how it is drawn. This is the tree what we already decided. 5, 6, 7, 8. Branch current 5, 6, 7, 8 are available in the tree. Now these lines are drawn. That is a link. 1, 2, 3, 4 is the link. Branch 1, 2, 4 form the link. 5, 6, 7 already available in the tree. Now we are making the tree into tie set, so that we are considering the branch 1, 2, 3, 4. Branches 5, 6, 7, 8 constitute branch voltage. Link current in the tree are shown as given or given by. Right. So I5, I6, I7, I8 already available in the tree. I1, I2, I3, I4 we connected in order to make it into tie set. The link currents are denoted by small letter I. So apart from I1, I2, another 4 currents are there. Small I1, I2, I3, I4. That is the link current. These I1 to I8 branch current. Right? The link current is denoted by the red color, small letter. Branch currents are denoted by capital letter I. So small letter I, link current, capital letter I, the branch current. Now we'll see how we can find the branch current from the link current. See this I1. I1 is nothing but this branch current I1 is nothing but link current I1. So same current is flowing through the branch I1. So I1 equal to I1. Branch current I1 equal to link current I1, small I1. Similarly I2. This I2, small I2 is equal to capital I2. Both are equal. Branch current I2 equal to link current I2. Similarly I3. Branch current I3 equal to link current I3. I4. Branch current I4 equal to link current I4. So I1, I2, I3 branch current is equal to the link current. But I5, with I5, this I1 also flowing and I2 also flowing. I1 is flowing downwards, I1 is flowing upwards. So the difference between these two current is the I5, I2 minus I1. First 4 same, branch current and link current. For I5, I6, I7 is the difference because two currents are flowing. Then I6, here I3 is flowing as well as I2 also flowing. So I3 minus I2. In I7, I3 is flowing and I4 is flowing. So I4 minus I3. I8, I1 and I4 is flowing. So I1 minus I4. So from the link current, we can easily identify the branch currents from I1 to I8. So these 4 links are available. I1, I2, I3, I4, the branch current can be computed. From the link current, we can compute the branch currents. So now see what is the tie set. The link current I1 is flowing through I1, I5 and I8. 1, 5, 8 branches. So the link current I1 flow through the branches I1, I5, I8. That I1 is not flowing through I6 and I7. Not flowing through the remaining branches. Only it is flowing through I1, I5, I8. Not flowing through I2, I6, I3, I7 and I4. So this link current I1 with branch current I1, I5, I8, this is the tie set. This is one tie set. Similarly I2, link current I2, branch current I5, I2, I4, another tie set. Link current I3 with branch current I6, I3, I7, so another tie set. Link current I4, branch current I8, I7, I4 is another tie set. So this is 4 tie sets are available. So the details are given. So what we discussed, the details available. The link current I1 traverse the branches 1, 5, 8. These set of branches form the closed loop. The link current I1 flowing through this loop. So this set of branch is called a tie set. So what we discussed, same thing. Similarly, we can go for a link 2, 3, 4. In that current I2, I3, I4 are flowing. That is also a tie set. If the network geometry is complex, the above method of writing tree branch currents may be tedious and confusing. For a complex problem, we cannot apply this method. So a symmetric way of indicating the link is given by using a schedule. So this is the tie set. Now we see tie set schedule. By making tie set schedule, it becomes easier. Table gives a schedule for the graph and the tree as discussed above. Now we'll see the tie set schedule. This is the tie set. What is tie set? Link current with the branch current form the closed loop, that is a tie set. Like that we have 4 tie sets are available. But only this tie set, if the network is complex, it is very difficult. So that we can go for a tie set schedule. Now we'll see how to form the tie set schedule. So before going to the tie set, some important points we'll see that. Note is there. We can choose any other tree. We chosen one tree, but we can use any other tree also we can choose. The direction of link current is so chosen that I1 flows in the direction of I1. Link current I1 flows in the direction of branch current I1. Similarly, I2, link current I2 flows in the direction of branch current I2 and so on. So, link current and branch current we are make it as same direction. I1 with I1, I2 with I2, similarly I3, I4. These are all the important things. Now we'll go to the tie set schedule. What is the tie set schedule? So this tabular column will give link number. This is a node 1, 2, 3, 4. There are 4 links are available. And 8 branches are available already we discussed. 1, 2, 3, 4, 5, 6, 7, 8. Now this plus 1, minus 1, 0 indicates 0 means the link 1 is not connected with branch 2, 3, 4, 6, 7. Only it is connected between 1, 5 and 8. We'll see the diagram. Plus 1 means is going away. Minus 1 means going towards. 0 means not connected. Now we'll see the diagram. Link 1 connected with 1, 5, 8. We'll see the diagram now. See this. This is the link 1 connected with 1, 5, 8. Right? The 1 is going towards. We'll take this is the link. This is towards so minus 1. This is also towards minus 1. This is away. So plus 1. So that is the thing available in the tab. Like that we can go for other thing also. So 1 and 8 plus 1, 5 minus 1. Here the plus 1 and minus 1 we can take this the current, link current and branch current same direction. So plus 1. I8 also same direction, plus 1. But I5 and I1 opposite direction. It is going down. I1 going up. So minus 1. Accordingly it is written. Both the currents are same direction plus 1. Opposite direction minus 1. Accordingly we can write remaining also. So this is based on that. This tabular column is done. This is called a tie set. So from this tabular column we can easily identify in link 1 the branch current 1, 5, 8 is connected. Plus 1 indicates link current and branch currents are same direction. Minus 1 indicates opposite direction. Similarly link 2, 3, 4. So from this how to find the branch current? I1 equal to I1. See this, in this branch current only I1 is there, remainings are 0. In branch current 2 only link 2 is connected. In branch current 3 only link 3 is connected. In branch 4 only link 4 is connected. So capital I1 equal to small I1, I2 equal to I2, I3, I4. So what we discussed in the diagram, the same thing reflected in the tabular also. In branch 5 I1 and I2 is there. So it is I2 minus I1. In I6, I2 and I3 is there. So I3 minus I2 plus First we'll take the plus, then minus. I7, I4 minus I3, I8, I1 minus I4. The same thing only we discussed in the tie set diagram. The same thing here reflected in the tie set schedule also. So in this, the first column consists of link numbers 1, 2, 3, 4. These pertain to the 4 loops causing 4 loop current I1, I2, I3 and I4. So the first column is the link current, that is due to the link number, that is due to the link current. Now we'll analyze this tabular column. First we'll go to the first row. We are going to analyze the first row. Some analysis, what we discussed is available in the Wadding's. Description is available. If branch current and link currents are in same direction, insert +1, opposite direction -1, that we discussed. No, not flowing means 0. First we'll analyze I1. I1 is flowing through branch 158, forming the tie set. So I1 flowing in branch 158 is the one tie set. In first row under the branch 158, we entered 1, -1 and 1 respectively. That means this 1 refers that branch current 1 and link current are same. Similarly 8. Only in 5 both are opposite, so -1. So I1 is not flowing through the branch 2, 3, 4, 6 and 7. So in the first row we wrote the zeros below the branch 2, 3, 4, 6 and 7. So what we discussed, the same thing is given here. Only 158 link current is flowing. In that 1 and 5, 1 and 8 same direction, so placed 1. In branch 5 opposite direction -1. 2, 3, 4, 6, 7 the current I1 is not flowing, so placed as 0. Similarly we go for the second column, second row. So in the second row I2 is flowing through the branch 2, 5 and 6. 2 and 5 same direction, so +1. 6 opposite direction -1. So that is given. That I2 not flowing in 1, 3, 4, 7 and 8. For that we placed 0. Similarly we can go for a third and fourth row. We can fill up the elements. Each row of the schedule indicates the element of one tie set. So the every row indicates indicate the one tie set. The entire schedule consists of 4 rows corresponding to tie set is called a tie set schedule. Every row is the tie set. Entire thing is the tie set schedule. So with the help of this, with the help of the tie set schedule, branch current can be written in terms of link current as we discussed earlier. That is branch current I1 equal to link current I1. Branch current I2 equal to link current I2. So from the tie set schedule, we computed the branch current in terms of link current. So that is given here. So in this video we discussed the tie set schedule. What is the tie set schedule? How to frame the tie set schedule from the oriented graph. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.